Remember that an atom contains the same number of protons as electrons. Therefore, atoms are neutral and they do not have charges. So if we were trying to figure out the protons, neutrons, and electrons for these three, we would just look on the periodic table and know that our protons and electrons should equal each other. Go ahead and pause the video and figure out these 9 boxes. Restart when you're done. So our first element, chlorine, has an atomic number of 17, so it has 17 protons. It would also have to have 17 electrons since there's no charge. To get my neutrons, 36 minus 17, you should have gotten 19. For sodium, which was here, it has 11 protons and 11 electrons, and then 23 minus 11 was 12 neutrons. And finally, calcium was here. It has 20 protons, 20 electrons, and 40 minus 20 is 20 neutrons. Ions, on the other hand, have charges. There's 2 types of ions. A cation has a positive charge, and therefore it has more protons than electrons. Metals and hydrogen tend to make cations. So you can remember cation because it has a T, which looks like a plus sign. You can remember cation because cats are good. Or you can remember cation because cats have paws, which make it positive. And then anions have more electrons than protons, therefore it has a negative charge. And so it's going to be an anion. Nonmetals make anions. So you can remember that by remembering ants are bad when they sting you, so ant, anion. So cations are positive ions, anions are negative ions. So an ion does not contain the same number of protons as electrons due to the gain or loss of electrons. You can only lose and gain electrons. Protons remain the same because that's what identifies what element you have. Therefore, ions have charges. So for this first one, we would say chlorine. We would look on the periodic table, find chlorine, and say, well, chlorine has an atomic number of 17. So my protons must be 17. Then I look at the charge. The charge determines if I have more electrons than protons or more protons than electrons. In this case, since I have a negative charge, I have to have more electrons. How many more electrons? 1 in this case, so 18 electrons. If it's a negative charge, you're going to add that number to your protons to give you the number of electrons. If it's positive, you're going to subtract that number from your protons, because negative means I gained that many and positive means I lost that many electrons. Since this ion was negative, that makes it an anion. Let's look at another one together. We have sodium. So we saw that one a second ago. So our sodium is over here. So sodium has 11 protons. The atomic number always tells you protons. If I have an overall positive charge, I must have more protons than electrons. How many more? 1. So I have 10 electrons. Notice I have 11 positives and 10 negatives, which gives me a net positive 1 charge. Since this one's a positive 1, that must be a cation. Calcium, which we saw earlier, has 20 protons. But since it has a charge, its electrons can't be 20. We have a positive 2, which means I need to subtract 2 from my protons, giving me 18 electrons. I've lost 2 electrons. Since it's positive, it's also got to be a cation. One more together. So sulfur's over here. Sulfur has an atomic number of 16, so we have 16 protons. Since it's got a negative 2 charge, that means I'm going to add 2 electrons to it, giving me 18 electrons. Finally, since it's a negative charge, that means it must be an anion. Go ahead and pause the video and do these 5 on your own. Restart when you have these 5 done. So there was nickel. You should have had 28 protons, 26 electrons, and you should have said that that was a cation. Notice we have a net of 2 protons. Phosphorus is down here. It's number 15, so we had 15 protons. It's a -3 charge, which means I have 3 more electrons than protons. And it was a negative charge, so it should be an anion. Aluminum has 13 protons. It's a +3 charge, which means you should have 10 electrons. And it was positive, so that's a cation. Magnesium is located here. We have 12 protons. Since it's a +2, you should have 10 electrons. And since it's positive, cation. And finally, nitrogen has 7 protons. It's a -3, which means I gained 3 electrons, giving me 10, and that's an anion. Notice that my electrons can be the same number, but different elements because the protons are what determines what element it is. So another way of displaying what element you have with lots of different information is isotopic notation or chemical configuration. In chemical configuration, you have the mass on top, atomic number on bottom, the symbol, and then your charge in the upper right, if you have one. If you don't have a charge, you'll just be left blank. It's a little confusing because if you look on the periodic table, we have average atomic mass on bottom and atomic number on top. The atomic number is always the smaller of the two between mass number and atomic number. So if we look at this example here, all the information I need is located right here. I don't need to look on the periodic table for anything because my protons is my atomic number, which was that bottom number. My electrons has to do with the charge. Since I have a +2 charge, I should have 2 less electrons, so 90 electrons. And then my neutrons is 236 minus 92. Notice they're lined up nicely. I just subtract the 2 pieces. Subtracting those out, you get 144. So you would definitely need to be able to fill out charts like this. So go ahead and pause the video and try these first 2 rows on your own. Restart when you have those 2 rows done. So for the first one, you should have said your atomic number was 17 because it's the bottom number. Your mass number should have been the top number. Remember that we're using whatever mass is given, not from the periodic table if we have it given. Protons should be the same as the atomic number, so 17. We have a charge of -1. Since I have a charge, my electrons can't equal my protons. I have a -1, so I should have 1 more proton or 1 more electron than proton, so 18 electrons. And then for my neutrons, it's mass number minus atomic number, so 42 minus 17 gives me 25. For the second row, we look at our protons and we look at our electrons. I have more protons than electrons, so I know the charge has to be positive. How many more protons than electrons do I have? 2, therefore it's a +2 charge. I know my protons is always my atomic number, and to get mass number, it's protons plus neutrons, which gives me a mass of 67. So to write my isotopic or chemical configuration, I do mass number on top, atomic number on bottom. At this point, I need to look on the periodic table and see who has an atomic number of 30. It's zinc. And then I put my charge in the upper right corner. Go ahead and pause the video and do the last 2 rows on your own. So for this one, we had atomic number 5, so 5 protons. +3 means I should have more protons than electrons, so 5 minus 3 gives me 2 electrons. And my neutrons should be 13 minus 5, or 8. For my isotopic notation, 13 is my mass, 5 atomic number. I now have to look on the periodic table and find number 5, which is boron, and that has a positive 3 charge. For the last one, we have 26 atomic number, so 26 protons, a positive 2 charge, which means I have to have 24 electrons, and 26 plus 30 gives me 56 for my mass. So 56 over 26. 26 is iron, and it's a +2 in this case. You also may see it in word problems like this. This is basically giving you the information that we would have had in the chart, but in word form. So since we're trying to write that chemical configuration, we need our mass number, atomic number, symbol, and then charge if given, or if it has a charge. So for this first one, we look and see what can we fill out. Well, we know there's 5 protons, and I know protons is my atomic number. So it must have an atomic number of 5. Since it has an atomic number of 5, I look on the periodic table, and that is boron. Then I say, well, mass is protons plus neutrons, so it must have a mass of 11. And then I look at my protons and my electrons. I see that they're equal, and therefore there's no charge. So I'm just going to leave that blank. I don't write a 0, I just leave it blank. So that would be my isotopic notation or chemical configuration. So go ahead and pause the video and try the next one on your own. Restart when you finish this second one. So for this one, they gave you the mass number, so we know the top number must be 17. But that's all they gave you, so you have to remember that mass number is equal to protons plus neutrons. And we know that that number is 17. They also gave you the neutrons, so protons plus 8 is equal to 17. Therefore, your protons must equal 9. And if I know my protons, I know my atomic number. I look on the periodic table, and atomic number 9 is right here. That is fluorine. And then finally, for the charge, they said that this was an atom. And atoms have no charge, therefore, this is my final answer. All right, go ahead and pause the video and do the last one. Restart when you're done. So for this one, they also gave you the mass number, so we know that it was 60. This one gave me electrons and charge. So since it's a positive 2 charge, I know I must have more protons than electrons. I have 25 electrons, so I must have 2 more protons than that, so 27 protons. Looking on the periodic table, 27 is here. So that's cobalt, and that's a positive 2 charge because they gave me the charge. And so that should be your answer for the last one.